我可不是耍流氓，到这里要当老大。我可不吃你这套，来到这里，我可不是耍流氓，来到这里当老大。
Of all man-made devices, we can say that the MOSFET is one of the most frequently used in our daily lives today. Although you may not realize it, we use billions today in our computers, our mobile phones, our gaming consoles. They can also be found in cars and electrical appliances and in the most unexpected places. Basically, they are found in systems where information is processed or stored. How is information processed? Ancient people already used communication systems where a small set of different and well-defined symbols are combined. The simplest of this is the binary system, which needs just two symbols for communication, the 1 or 0. When an electrical flow can pass through it, so there is no current, and in the on state, the charge can flow creating electrical current. In order to store and manage a huge amount of information and save space, these switches need to be manufactured as small as possible, that a microchip can contain billions of them. However, tiny as they are, they still need to work as electrical switches. There must be a part on the electrical switch that will allow the electrical charge to flow in some mechanism that will allow this. This switch is the MOSFET. Parts: metal oxide semiconductor field effect transistor or MOSFET is composed of P or N-type flow silicon. In this example, the substrate or base is composed of P-type silicon. Through iron implantation, two N-type regions are formed. An insulation layer is needed, is typically produced with silicon dioxide, and above this, a layer of aluminum is applied. Finally, the second layer, composed of silicon dioxide, is applied. And now, transistors are taken together. There is a P-type substrate with two strongly N-type regions, as well as the electric contact, which provides the transistor the necessary current and voltage potential, known as the source, drain, gate, and buffer.
So, how does a MOSFET work? First, we should take note that the source and the bulb are often connected to each other, so they share the same source of current. The objective of a MOSFET is to control the flow between the source and the drain. This is accomplished with the gate. There will be no current in the gate because there are no carriers of current are available between the two N-type regions. However, should there be a positive voltage in the gate, a positive electrical field builds up which attracts electrons in the P-type layer and repels holes. These electrons form an N channel and can carry electrons from source to drain. It should be noted that the current between source and drain can increase through raising the voltage potential, which leads to a stronger current field, and therefore a larger N channel.
So as we all know, there are two types of MOSFET, the depletion and the enhancement type. So now I will show you the characteristics of the depletion type MOSFET. Hello, this is the schematic symbol of the depletion emission MOSFET. This is for the N channel and the P channel. And we have here the basic construction of the depletion type MOSFET. As you can see, this is the drain, gauge, source, and another terminal called the substrate. And the P channel and N channel, and this is the silicon oxide. So, in the depletion type, the gate is insulated, and due to that, the input that we are applying to the gate creates a higher impedance. This is the reason why it is called as the metal oxide semiconductor. It is also known as the IG FET. IG is insulated gate field effect transistor. So if I will apply a voltage, and VD is the voltage applied to the drain and the source, the current will flow, so this will be the current. Now I will connect a battery with respect to the gate. So positive VGS been connected there. Now, what will be the effect on the characteristic of the depletion type? But before we look into the characteristic, I will show you the activity of the electrons in the circuit. The electrons will be attracted towards the positive terminal of the battery and will settle down near the gate. Therefore, the number of electrons in that channel will increase. Also, the electron from the substrate, which is the minority there, will also get attracted, and that would settle in that channel. As a result, the electrons will increase, so if we apply VD at the same time, the current will also increase. Now, disconnecting VGS. So, disconnecting the VGS battery and applying another battery with opposite polarity, what will happen is that the electrons, they will get repelled and will go towards the substrate. So obviously, the electrons in that channel will decrease, as well as we increase VGS, the current will also decrease. So this is now in the enhancement mode. And this is in the depletion mode. So if my VGS is less than some value VP, then the channel will disappear. If my gate source voltage VGS is less than 0 but greater than VP, the channel will, then my channel will somewhat decrease from the default state. But I will still have an ID which will be greater than 0, and this will be and this is when we put the channels on the depletion region. And in the third case, when VGS is greater than 0, then the channel will increase. We'll have an ID value greater than 0. Again and again, and this is in an enhancement region. So these are the key things to recognize for the ranges of VGS. Now, recalling the relationship between ID and VGS in JFET, it's ID is equal to IDSS, drain source current at saturation, times 1 minus VGS over VP squared. This also applies to depletion MOSFET. The only difference is that the VGS here can now go positive. And here we have another picture for the depletion type MOSFET with the relationship between VGS and ID. Here is my IDSS, which will be the maximum that I can have for my drain current for a JFET, but because we are dealing with a depletion MOSFET, it allowed me to increase beyond my IDSS here. So we have here a similar relationship between ID and VDS, and the scales the same, and it only shows that for different VGS values, I'm gonna have a different relationships, different saturation currents, and different points.